Okay, perfect. So I'm a bit take time to update a little. Some slide was not apparently visible correctly. So I will continue with the coding parts. I will pass again quickly on some part and continue after with the adiabatic and cooling tower. So just to refresh a little, calculation power, it's electric power and it will generate heat. This heat, you have to manage it by any way, to recircuit or to extract it outside from the building. Two kind of cooling, air and water, but in all the case, or almost all the case, you will have water or similar liquid into your circuits. We see the different charts, vaporization charts and psychrometric charts. To do a quick reminder, each system will have an external system, remote system outside the building, and an internal system, generally for fresh air or a direct cooling system for compute parts, direct cooling into the compute parts. First of all, we saw the dry cooler. So the basic cooler every building can have, especially in Africa. So you have the hot water going inside, some metal pieces to do an exchange between water and air, to put all the warm on the air and the cold on the water, to have an external water cold and an external air hot. You will use electricity to transfer heat from water to air. So you will have hot water inside, cold water outside, and the reverse for the air. Cold air inside, hot air outside. If you want to optimize it in not really good solution, in a not really good situation, you will be able to use an adiabatic cooler. It's exactly the same than the previous one. Oop, little mistake. Up, not really better. Not better. You will have exactly the same here. You will be able to use it with only power, but this time in not easy situation, you will be able to use water to optimize this exchange. So you will just have hot water and vapor out. Here's the schematics. Was too small previously. So we use this little effect, the difference between humidity, to optimize the exchange. If we look at more bigger, the normal use, we have water into metal pieces. We optimize the contacts area on the metal pieces here to transfer heat from water to air through the metal parts. That is the normal and standard conversion to have cold the water. In the case of a diabatic tower, we add water in the air through the metal pieces to optimize the exchange coefficient. So we will continue to exchange heat from water to air through the metal parts, but also through the little water particle. And we saw After that, the cooling tower. Something I forgot to precise just previously, it's the cooling tower will use water in the air. The water will be maintained at a temperature between 25 and 45 degrees, which is the best environment for bacterial. So be careful when you use water on a water cooling system. It's a dangerous area for bacterial point of view. That was a little aspect I forgot just before. So the cooling tower, it's exactly the same system as an adiabatic tower. You will optimize your system by use water, but the main difference is this time you will spray the inlet water, the hot inlet water, so the water from your data center. You will spray it into a lock area, almost lock area, to exchange directly in the air. You have a water tank at the bottom part who will get all the water from the spray, except the water was gone in vapor. Because you're losing water during this manipulation, you have to add cold water from a water supplier or from a tank. So this cooling tower will use power and losing water, and it's exactly the same than the adiabatic, but this time, if you have cooling tower, we have to use water. It's not a choice. This time you have to always use water to put enough pressure into your circuit to don't lose it. Here you have a better view of it with this time fan here and here to push air correctly from the bottom to the top to optimize the air flux and the heat exchange. Here we can see the part of water will goes out as vapor, and this part with maybe not really clear. It's a metal fit optimization for the water. It's to optimize the exchange of it and the water tank, of course. Into a data center, you will need an internal water circuit. You have your IT room, data center room, compute room, and inside this room you will have an air regulator. We will see that after, or a direct cooling to the IT to the rack itself. In main system, in lots of different system, it's very useful to have two different circuits and a chiller at the middle. We saw that many times, and it's very useful because you can distinguish both and regulate correctly and differently the pressure to the compute room and to the cooling tower, because cooling tower are of course adiabatic or dry cooler, because your external cooling system will going outside will have optimized condition to work. So we will need specific pressure, specific water flow, depending of its activity. And it's not the same than what's it's needed into the computer room. Maybe you will need higher pressure, higher flow rate for sure. And it's not always the same than your cooling system, external cooling system. So the best way is to do two different circuits. Of course, if you only have air exchanger and a cooler, external cooler for a little data center, maybe it's not necessary to complicate with a chiller in two different circuits. But in many installations, it's really useful to have a better regulation. So into your circuit, you will have pipe, of course. Short distance is a better way, but take in account that it's better to put at the same level your cooling system than at the same level as your data center room to prevent to have a stronger pump, to prevent large distance, or to prevent any leaks through the computer room. Generally, pipe going through the bottom. And of course, if you are in a dry environment, desert or really hot situation, a water tank is really useful to be independent from the water supplier in case of problem. Into a data center, you will have data center connection that is really, really common because your system have or will be moved. For example, if you change your system, you will change your connector, etc. So you will have to segment and optimize each segment of your infrastructure. For example, you have one rack, one internal system. It's better to have two valves and two different connections for each rack to don't mix water from rack to another, to didn't mix also if you want to shut down one rack and not the other, if you have some pieces to change, or in case of leak. You will use a lot of different valve, pressure valve, standard, two-way, three-way, etc. The water security inside the room itself, the computing room, it's really important. You have electronic components and a leak will damage them really hard. To prevent that, you can put in place some sensor like this one or like other to find any leak into your data center. You will be able to put it into your rack, into the false floor itself, or directly on the ground. Just to have an alert in case of leak. Of course, on the floor itself, it's not really useful because you will be able to go into the data center and visually see you have a leak. The best is to put this kind of sensor into the hide parts, into the computer itself, into the rack itself, on the non-visible parts. The monitoring is also really important because of course, you don't want your server going in overheating states, but also to optimize your circuits. You will need for the main information you will need is pressure, water flow, and temperature. Temperature is the minimum information you need from your infrastructure. The pressure and the water flow are really, really useful. And the last point to see and to check is the air into the circuits. When you use an open, we would like to say an open solution, like a cooling tower, you will have a water tank. So for sure, you will not have any air particle into your circuit because the tank will have the rule. But in a closed network like this one or this one, it's possible in case of leak or in case of change of different components to put some air into your circuit. So you need to have an air extractor on your circuit, or at minimum to have some security to be sure you will not put some air into your pump or other components that really dislike air. And forget the last one, the valve, pressure valve bypass, because of course some system could be closed, some racks or infrastructure could be closed, and you don't want to see your pressure increase into the system and broke it. So two solution, pump with automatic pressure regulation to prevent any overpressure or pipe explosion, or a bypass to be sure if the pressure increase under a certain arm of bar, that will automatically open and protect your installation. We always spoke about water, but water also come with a little issue. If you mixed some metal, some specific metal, each other, you will have galvanic corrosion. This galvanic corrosion is mainly parts of your system when you have copper, aluminium, nickel, or some metal mix like this. You have to be sure all your system is in the same metal to be sure you will not going to this kind of problem. And in case of you have to discover this kind of problem, you can go with a voltmeter and check the voltage on your circuit, because it's battery effect, tension generation effect. So you will be able to analyze it, discover it, and find from the voltage generate which metal mixed you made. Some automatic system are available to check it on your infrastructure in continue and alert you in case of problem. This galvanic corrosion is really frequent, especially when you use only water into your circuit, when you mix metal. And the easier solution to prevent it and also prevent bacterial or bacterial problem is glycol. Two kinds of glycol are mainly used on the hydraulic system, ethylene glycol and propylene glycol. Two of them have specification, melting point, etc. Depend of where you install your data center, what is your need, if it's closed, if it's open, etc. In case of a water tower, you will not be able to use glycol in this circuit. First, because it's pollution, it's expensive, and also because if you mixed oxygen and heat on ethylene glycol, you will generate acid, three kind of acid, really dangerous. So that is your best solution to prevent the galvanic corrosion or to reduce it at maximum. But you have to take care because it's a dangerous product. The air-cooled parts. We will concentrate now on all the air cooling aspects. So more air cooling coefficient, etc. Did you have any question on the water cool parts?
Please, is there any question?
Yeah,
No question, Tom.
perfect. So come back to the air-cooled system. When I spoke about air-cooled system, as you see previously, we always use liquid and cooling tower to cool the air. So the main part is the cooling system in the water part, of course, but you will also have air in all data center and you have to carry on it. The most important point is condensation, the water into the air. The water is always your big enemy for all electronic components and you have to regulate it correctly. If you regulate it correctly, like the chart, you will be able to see it here, you will optimize your heat exchange coefficient and you will prevent any damage on your electronic device. A lot of different solutions can be put in place, condensation, drainage, etc. We will see that just after. Basic air cooling system into a data center, it's always or mostly the same. You will have hot air generated by server. You will extract it from the top because the hot air going to the top. You will colder it like this and put it into the false floor reset floor. They will going on the racks at the front of the rack, like little open like this, and going again and again and again. The best way is, of course, to optimize your data center to have air corridor, to have cold rank and hot rank. Of course, if you have only 1, 2, or 3 rack, it's not really useful, but it's always a good practice, not only to optimize your system, to optimize the feeding into the data center, but also to optimize the cost. Because if you're doing air corridor, you will optimize the air conditioning function, and you will optimize the heat exchange. Also, all material will be used and arranged for the air flux. For example, you will be able to find a Cisco switch with reverse fan, depend of if you want your Ethernet connector at the front or at the rear. For many servers, it's exactly the same. You can have PSU and fans reverse if you want to have your front or your back hot or cold. So it's really easy to manage it by material. The humidifier. As I said previously, humidity coefficient it's really important to the data center because it will optimize the heat exchanger, and if you don't take care about it, it will damage your electronic device. A standard air-cooled solution like you have in your room actually or everywhere else will use a fresh that is the other part, sorry. Will take fresh air and extract air and vapor from the data center. Of course, Of course, inside the data center, it will look like this. You will have warm air inside and fresh air outside. If you have an water extractor, the vapor will going outside. If you didn't have this kind of system in your data center, when the air going inside the heat exchanger, you will put vapor into the room. Some data center room depend of your region, depend of the climate aspect, will need more or less humidity inside. Because of course, if you have an humidity at 80, 70%, it's really bad for electronic components. But your exchange coefficient is higher. So under 70%, it's become dangerous for your electronic device. So you have to reduce under 70%. Yeah, it's good. You have a good coefficient and you can't damage your cannot damage your electronic device. Good. If you're going under 20%, just an example, you will reduce too much your heat exchange because you will not have enough humidity. And another really bad aspect is if your air is too dry, you will also generate electricity in the air by sand, by movement, and you will generate a little quantity of static electricity, and that could be also dangerous for your electronic device. So you always have to maintain an humidity at a good level, and you have it on this anthropic massif. And I have just in mind, you will be also use this one. Yeah, it's not 24, it's more 30, but the fact is. On some data center, you will be able to use two kinds of solution to increase and decrease the air into the data center. You will have a vapor injector, so it's quite easy. He will just warm water to generate vapor and inject it into the air unit. So the vapor will going through the raised floor with the fresh air. And to reduce humidity, the best solution and easy one, it's a draining tank. A condensation draining parts will put water into this tank and this tank will be evacuated. That's the easier system for the air, water and air condensation. To optimize your air flux, your cooling area, you have a lot of different solutions. You can lock your row by some, I would like to say, some plastic container, some isolating, some little room into your data center to prevent any air exchange between the hot and the cold row. Of course, lose a little seal just to prevent any surpressure, overpressure problem. By containing like this, you have two solutions. The cold air outside, hot air inside, or the reverse, like this. Cold air inside, hot air outside. The more efficient one is this one. The cold air inside and hot air outside. Of course, both are efficient, but this one is more efficient because you will, by pushing air with the air unit, you will generate an overpressure, a cold air overpressure here, and that will optimize the fan function. The other good aspect is if you're going to the data center, you will not feel too cold inside. Some data center room have a temperature at 20 degrees. And it's not really funny when you come from outside with 40 degrees and going to the data center on 20 degrees. So this solution is a more efficient one and the more, yeah, the more easy one also to put in place. Put a cabinet, it's really easy. Other solution exists. You can put a water-cooled door also to have an fresh air inside and an hot air outside server who will be maintained into the rack. So your hot air will be into the rack, and after passing through the water cooler will become cold again. That prevents you to have a big air cool system into the data center. You will optimize it by putting water cooler on the rack, and it's perfect. Another solution is to create a loop into the rack. You will have a rack like this with all your server inside, a rear part accessible, but the rear part will be closed by a door and will contain all the hot air. The hot air will going through another corridor into the rack and pass through an heat exchanger like a water cooler, and that will push again the air at the front. That is another solution, and you can have a last solution with like a little data center into your data center just for the air. You will have a door here and here for your rack, and you have a total exchange here. And the last solution is to, it's really, yeah, it's almost funny. You have one rank with your server cabinets and another rank with your heat exchanger, and you will be able to put a cabinet just to have 2 cold corridor and 1 hot corridor. All their solutions are to optimize your air system and to make it more efficient. All solutions have advantage and disadvantage. Generally, it's a cost to put this kind of solution in place, but you will always gain in your global air efficiency. That's all for the cooling parts, air cooling and water cooled parts. Do you have some question on it?
No questions. Okay, there
Okay.
is a question. Please hold on.
Mr. Tom,
Yeah.
thank you for sharing with us. The cooling of the room and the cooling of the data center, of the cooling of the data center. If you cool the data center, can someone stay there? Because what I'm seeing at the end of your presentation is like someone can stay inside the data center. But of the little knowledge I know that the data center can be away and you have your extra office by the side, because that room should be very cool, above or below 20 degree. Just what I'm seeing here, below 20 degree. Can anybody stay inside the data center, or you have to have extra office outside the center?
In fact, generally it's a specific room we use for the data center, and going under 20 degrees, it's useless because your electronic device didn't love really cold temperature and have an optimized temperature point at 27 degrees. So if you put air under 20 degrees into the server, it will be not really efficient, and of course your data center will be not really, you will not feel really good into the data center itself, and it will be quite difficult to maintain this temperature. In fact, between 20 and 25 degrees, it's the best air temperature for a data center. It's more easier to maintain, it's more efficient for server, and it's more efficient for the heat exchanger. After that, in fact, you will be able to use the hot air to, I don't know, warm some other building on other room or rivers, for example. But yes, you have to be careful about the temperature you let into your rack. Their temperature are really restrictive. Of course, we have example with 10 and 20 kilowatts server. Of course, you will be able to have a really more powerful server inside. And yeah, if you have a direct cooling solution, you will not need air-cooled solution anymore. I don't know if I clarify correctly your point, or.
Okay, I get you. Like the server of 20 kilowatts, right?
Right, it's just an example.
An example. Okay, if you have a server of 20 kilowatts at a maximum, and your cooling room should be maybe the door, the cooling door, like the door of the server, should be at
Not
35
enough.
35 degree, right?
Yeah.
Is it the
The
door or the room itself?
oh, the example with the water cooler. In fact, it's the air will going into the data center outside of the door. You will have water inside at a temperature at for example, 20 degrees, water at 20 degrees inside, and it will change the outside temperature from that to that. But that is only an example. Of course, if you have a server complete rack here at, I don't know, 70 or 80 kilowatt in total, of course, the water cooler will be not enough to exchange correctly the air, the heat. So you will need a global air-cooled system to cool the less, I would like to say 10 or 20 degrees hot left.
Okay, which means no one can stay inside the data center more than 10 minutes.
Oh,
If no one can stay
oh,
there.
in fact, you will into the data center. We will never have a temperature like this, of course. I mean, this temperature is an example when you are directly at the rear of the rack. Of course, the data center normally have a temperature maintained between 20 and 30 degrees. It's a minimum. Yeah, it's a normal temperature into a data center, 20 and 30 degrees. A data center have to be accessible in all the case.
Okay. Okay. Thank you.
You're welcome. No more question?
Yes, no more questions.
Good. To be honest, I didn't expect that parts will be really easy to understand. So quite surprised, but good surprise. So let's go to the room recommendation. First of all, the room localization into the building. Of course, your data center, it's really rare you have only a building for a data center. Generally, you have office, you have meeting room, you have conference room, you have many other room into your building, into your data center. So you have to choose correctly where you will put your room. Always depend on the usage. First of all, the step. If you have too much step to access to your data center, it will be difficult during the installation and during the maintenance because you will have to carry on a lot of, maybe not a lot always, but during the installation for sure, a lot of big and heavy pieces between different stair. So prevent to have too much step between data center and maintenance room or storage room. Also, another solution, good solution, is to have an office just near the server room. For maintenance people, sysadmin, people who need quick access and most often access to the data center. That will always be the case because an HPC system have to be maintained and you want to have someone on site with an office on site almost to do the maintenance, change pieces who will be failed, change components, modify some subsystem, firmware update, etc. Also, some company like to have the data center and server, I would like to say visually exposed to the rest of the building, like an entrance in the big main room, etc. It's not a good idea because some people will easily have access to physically to your server and have the possibility to change, hack, steal some data, etc. So it's not really good. Also because you have to control the cooling of this room or almost the cooling of those rack, and that could be not really easy. So the best solution, it's something like this, with a data center protection, physical protection for the noise, for the temperature, for regulate security access. And there's a room with, for example, some desk and storage for material to change, people who need access to the machine, etc. And of course, like I said previously, be careful about the stay of your data center. For the room itself, a data center room, it's, normally you have a raised floor, it's classical. to be able to manage the cabling, to be able to manage power cabling, any cable tree, water prevention, water pipe, etc. A lot of data center have raised floor, especially for HPC. Another solution for the cabling, it's a cable tree. Cable tree, you will be able to put it at the raised floor for sure, but you will be also able to put it at the top of the data center room. Keep in mind you have two things to put from the data center itself to the rack is the power supply and the network connection. Both can't, or it's not recommended to put the both in the same cable tree because your Ethernet signal can be disturbed by the electricity itself. So you can mix fiber and power supply, but prevent to mix Ethernet cable or copper cable with power supply. That will save you from many trouble. The piping will be at the bottom parts when you have piping, of course, if you have water cooler, if you have direct cooling system, or also when you have heat exchanger directly into the data center room, which is the case for many data center. So in those cases, raised floor is always useful. And the last point is the security. The security into the data center, it's very important. The room have to be accessible only for interesting people. I mean, sysadmin, people who take care of material itself, hardware itself, etc. If you want to let your cluster accessible for some visit, presentation, etc. The quick solution is to put this kind of wall to let people outside the data center but have visible access to the data center itself. Or another solution is to lock the rack itself, just to be sure the people will be able to going into the data center room and not be able to access to the rack directly or component inside the rack. Of course, if you have different company, different customer in the same data center room, it's also a good solution to share correctly and regulate correctly access to the rack. It's really easier to install this kind of little security on a rack, for example. And the last point, it's a security. Camera and fire alarm, access alarm should be really useful. Camera, you will be useful also to regulate access and to the insurance. We spoke about insurance previously. Insurance people love camera because they will be able to see who is responsible or what is the responsibility of any problem into the data center room. And it should be also really efficient for security guys for big building who have security guys inside. For the security, three kind of security: leak, fire, hack. Hack, I put a little asterisk because if your data center is not accessible physically for people, other people than administration people, you will not have this problem anymore. You will have only to take care of your network access to be sure, of course, to protect it correctly, but you will not have hacker problem anymore. Fire alarm. So fire alarm, it's first point. The second point is if you have a fire into your data center room, you have to cut it quickly and without damage your already expensive material. The best system, of course, is gas, some argonic gas or something like this to cut oxygen into the room. So people inside the room have to quit the room as quick as possible, of course, but your fire will be down really quickly and your equipment will be not damaged. Sprinkler water into the data center room is also really efficient, but it can damage your components. So if you put sprinkler or other fire solution like that, you have to take care about your rack model, just to be sure the rack will prevent component from water intrusion. To speak about water, of course, if you have some water into your room, the water could be also a problem, and you have to put in place some sensor and be sure you will be able to find a leak before this leak will damage any component or any equipment. Generally, is sensor like we see previously. It's it's metallic cordon. You will put it on the raised floor, and it will detect automatically any leaks. That's for the room parts. Any question on this aspect?
Please ask questions. Any questions? No questions, Tom.
Okay. We're going our way. Network aspects. Of course, your data center have to be connected to your enterprise and to your enterprise network, to your company network, to another building if your data center is outside the principal building. So you have to take care about this network, because this network is really important for your HPC cluster. First of all, the redundancy. Never have only one access point to a cluster. You want a main link and a backup link. Be advised that you will have to transfer big data, sensor data, input data for your jobs. That could be really big for some customer. So you will need really high bandwidth. And the second point is, if you want to do an SSH connection, you don't want to type a command line and have the answer 1 minute after. So a good connection with a little ping with a low latency, it's better. Redundancy. Your principal link could be fiber, for example, and you can have a redundancy link like Ethernet basic cable. In fact, you normally may not lose your first link or your first solution. Have two big links and share your bandwidth between the two big links. It's also a good solution and prevent you, if you have one link down, to have the second one available. And also, when we spoke about external connection, we have to speak about security. Normally, you have your company or business security, like VPN, firewall, access control, etc. That should be enough for your company, but your HPC system may need a specific security, because of course you don't want someone from outside who going into your data center and, I don't know, take some data they don't you don't want they have. but maybe in the same company, you don't want to let your server or your HPC cluster accessible from anyone. So take care of the first cycle, the security into your company itself. You can put a VPN protection into your own company network if you want, but normally it's not necessary. Just an access control, a gateway should be enough. And after that, you will maybe expose your cluster on internet for some specific customer. At this point, you will need VPN connection, encrypted connection, or almost securized connection to be sure you will not let the access at anyone not allow. But also if your customer or you want to transfer some critical data to the cluster, maybe you don't want some people to access to it. So the security is very important for the external network connection. The security for prevent any hack, leak, data leak or something like this, but also network security itself that like redundancy or high availability solution. That's all for the second part. Do you have any question on the building data center cooling parts?
Mr. Tom, sorry. Thank you very much once again. Can I get a video or or a material, something pictorial that I can be able to see the real connection of the hardwares? Can I get an access from you?
Sorry, I misunderstand the question.
Okay, I said, can I get a video showing how these things are done? A video
Video for what?
for
Of
the
what?
cooling of for the cooling of the data center, and as well for what's the last? And for the room that you just show us, how the room is done.
I think I misunderstand what is your question. You want a video of the data center? Or
Yes, yes.
why a video of the data center?
Hello.
Hello?
I'm not sure, but I think he want to say the interact between different element of the data center. In for example, in like uh, a begin to the begin of the and the end of connection between the user and a case of use
Ah, okay. Understand.
that will
So,
help us to know what the different part of each piece um, of each piece of cluster, and when each piece will interact with the other piece and why.
more on the cluster infrastructure. I mean,
Yeah,
cluster-based infrastructure.
like in a telecom telecom communication. When in a GSM or GPRS, when end user will call another end user, where the communication are served in the network, and what piece of what piece of perhaps the BSC, the RNC, uh, when they enter, when they come in the
Ah,
communication, and why, what the main task they do, etc., etc. This, like in here in this case, our if they're
okay.
possible.
I understand. I think I understand the question. We'll clarify just to be sure. You want a specific description of would like to say an image of which kind of solution, an example of solution we would be able to put in place to connect remotely to a cluster, and some user case. So in which kind of situation and who will be able to use a remote connection to a cluster. Is that your question, if I could understand?
Yes, Tom. Yes, exactly that. Yes,
Perfect.
the use case.
Perfect. So, how I can show that? Where I can show that? Okay. I will go very previously. A cluster. To go back to the cluster itself, we see on the cluster we will have many different nodes. We will have compute nodes, management node, visualization nodes, etc. That is a view of a really complex cluster, maximum complex cluster, and that is a simple cluster. Starting with the simple cluster, you will have only two elements who will be exposed to the enterprise network, to the company network, to the rest of the company network. The login node and the management node. Into a company, you will have an isolate network for the cluster. This network is the cluster network and will be connected only to cluster elements. You will not have any other network connected to this one. The admin from the company will be able to connect with a specific network to the management node. Only the administrator from a company, from the company network, will be able to connect to the management node. The users, scientists, etc., will be able to connect always from the company network to the login node. The end user, so the scientists, the people who will push some job on the cluster, will use the login node, a specific account linked to each scientist from the login node. All the sysadmin, software expert, engineer expert, etc., will going through the management node to administrate the cluster. On a complex infrastructure, it's always the same. You will have the cluster network, which is totally independent from a company network, and you will have a couple of internal, external connection. You will always have the management node accessible from admin people. You will have the login node accessible from company user. The visualization node will also be available for scientists and user. And the gateway. Generally, when you have a gateway on your cluster, all the external connection will be passed through the gateway. So the cluster will be connected to company network only from the gateway server. And it's the same if you expose it from outside, from internet or from a VPN. You will always have a gateway server to be sure the connection to the cluster is secure and protected. Because if you have access to this network, you will be able to access to all the components of the cluster, and that will be dangerous for unauthorized people.
Question, please.
Yeah.
Um, 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 in the case where I'm in Senegal, I'm in France, and I want to connect the in the data center which is in Senegal. I will enter by the gateway, and the policy and they and the logging node will tell if I have the if I'm able to do this or not. My
If you,
in my understanding,
yeah,
the user have to connect with the system by logging node. But if I am outside from the network, I have to connect in the network by the management, no, by the gateway node.
yeah,
In the fact, if I am in France and I want to connect in the um, data center, which is in Dakar, what is the path?
that that isn't a question I can explain very quickly because I was part of the Senegal cluster installation. Actually, the only access point to the Senegal cluster is a login node. Only one login node is exposed to internet directly. So in this case, it's a specific case because it's a specific cluster and not a really, really big cluster. You have a direct access to a login node. This access to the login node, it's only points to enter on the cluster. You didn't have a connection to the storage, management node, compute node, and you didn't have any other PCs. So access, it's a login node. So in the Senegal case, the login node is also the gateway node, is also the more secure node. We have firewall, fade to ban, access rule, etc. For the administration people, if an administrator wants to connect, for example, from Dakar to the management node, he has to pass through internet to going on the login node with a specific admin user. And after that, from the login node, it will be able to connect to the management node directly. But he have to pass through the login node with only and single points to enter on the cluster. That is generally, it's generally the use case for a little cluster or not really big cluster. Only login node are exposed from outside. The management node is connected to the cluster and connected to the internal administration network, but you will never have a management node directly exposed from outside. That is the point. If you want to connect to a management node, for example, I will take a public example in the CEA in French. The CEA in French, the CEA cluster, it's totally permeable. It's not accessible from outside. No one from internet is able to connect to this cluster. No internet access possible. It's only internal access. So if you are into the building, connected to the company network, okay, you have access to, you are able to access to the cluster, but not from outside. If I take another example, the most famous one in French in Europe, Ulrich. Ulrich cluster, you will have login node and you will also have gateway nodes. The gateway allow people from outside to access to the cluster and to access to the login node. So from outside, you will be able to connect with a VPN, virtual private network, to a specific network into the company, to access to the gateway server, and from the gateway server, you will be able to access to the login node to push some job if you are a user, if you have a user access, or if you are an administrator, you can connect from the gateway to the management node to administrate the cluster. And that is another example. You have to use a VPN to connect. So in fact, if the cluster is accessible from internet, the best way is to use a virtual private network to be sure you will your connection will be secure, correctly secure, or if you use a standard access public IP address, just to be sure the gateway, because it's a gateway or secure login node, is in DMZ, demilitary area, demilitary zone, just to be sure you will not expose the rest of the company network to internet or the rest of the cluster. You're welcome.
Thank you. Thank you very much.
Any other person has questions? Questions, please. No further questions, Tom.
Okay, perfect. I miss for the number, so we will going through the last part, the third part, the physical deployment and maintenance. So if I go in here, so much better.
Tom? I think there's a question on the chat.
Oh, sorry, I didn't look at. What are the possible consequences of glycol leak in a HPC cluster? That is a really interesting question. First point, depend of where is the leak. If you are on a direct cooling solution, the leak could be into a blade, into a compute blade, or into the rack itself. In this case, the glycol will be able to damage some components to make a short circuit on the electric components. So you will have damage on one rack component or into the rack itself, many components. Normally we have sensor into the rack when we have a direct cooling solution. When we have, for example, pipe leak or hydraulic system leak, water-cooled door leak, generally they are made and secure to not be linked with the rack itself in case of leak. So the glycol will not going on system itself, not on the server, not on the login node, etc. All their parts will be protected in case of water-cooled door or other water-cooled solution into the rack itself. And again, normally you will have a sensor into the door or under the rack to be advised in case of any leak. If the leak is under the floor, the raised floor, or somewhere on the infrastructure, normally you will not have a lot of electronic components exposed. It's more for the infrastructure itself, for the efficiency of the infrastructure. But again, after a couple of minutes, if I would like to say hour, depend of the leak, a sensor will be activated and you will be advised. The main risk for the glycol, ethylene glycol, propylene glycol, is for the health itself. If you have some glycol on your hand, for example, be careful because they will become acid and it will attack your skin. So if you are exposed directly to glycol, you have to wash your hand as almost as quick as possible to prevent any damage. It's also it will be also a damage if you have that in your eyes or in your mouth or in other body parts. On component, it's dangerous for plastics because it will attack plastic parts, but it's mainly for metallic parts will be attacked by glycol when it will be dry, because again it will generate acid. The last point is generally glycol. It's an addictive, so you will have at maximum 50% of glycol. You will always have a couple of water with the glycol. So it's the water will make short circuit or electric damage. Maybe the last point with the glycol, it's be careful with child or dogs, animals in general, because glycol have a sugar taste. So it could be dangerous also for that, but normally you will not have animal or children into the data center. So it should be okay. You're welcome. Any other question?
One more question.
Thank you, Thomas. Oh, Tom. Thomas.
No problem.
I didn't say you mentioned I would like you to talk on the cable management area more. I imagine a lot of cables, different categories.
Yeah.
I'd like you to touch, maybe show graphically the way you've illustrated other ones.
Yeah, I spoke a little about cable during the first part, and I will spoke about it after too. Don't worry.
Okay then.
On these parts, aesthetic parts. So I will spoke again a little about cables. Of course, you will have a really big quantity of cable. At the preparation part, you only have to take care about where the cable will come from and where they will going to, because you will have connection between a rack, you will have connection with between a rack and customer infrastructure, etc. You will have to manage those cables, so you will be able to put a cable arm on server itself. In the rack itself, you will be able to put cable tree directly on under the racks. And because you will have a big quantity of cable, it will be useful to have a good cabling management for aesthetics aspects, but also for maintenance. And we will see a little more in detail just after for the cabling. But thank you for your answer.
Okay, thank you. You can go on to the next session.
Yeah. Too far. So, physical deployment and maintenance. The first point is the site preparation and the site review. We saw previously how to choose cluster component, how to choose and increase data center. The first part, when you have to deploy it, install it, is check the data center if is okay to install, is it able, of course, to have the solution inside, water cool solution, for example. If you have a direct cooling rack, the question will be, do you have a water cool solution, enough power to carry on it, to exchange, etc. So you will have to check all the previous points before the working into the data center to prepare it for the delivery, and you have to check it after the upgrade. Of course, if a data center was planned to I don't know, to get some Sequana water cooler rack, you will have to check all of this to increase the capacity of the data center or to adapt it to be able to connect a water cooled direct solution. And after all this work was done, you will be able to do a second visit and to check if all the work was done correctly, and if it's ready for your infrastructure. So 2 visits, and always the same point to check: electricity, cooling, room itself. You have to check also the raised floor if it's enough strong for your rack, for your material, etc. And also you have to check the access ramp, etc. for the trunk. So the first part is the site review. Check if the site and the room is ready to install a cluster. And yes, I forget a little point. In some case, you will be able to test it. You will be able to test each electric connector, each hydraulic connector, to be sure they work and they work correctly. Installation preparation. You will have to prepare your tool, because some racks necessitate specific tool. For example, nobody is really prepared to use plumber tool, or didn't have plumber tool to be able to connect correctly a direct water cool solution, to connect an adiabatic tower or something like this. So carry on tool, plan, check the plan, the racking, the room layout, the hydraulic electric plan, schematics, to be sure all your installation will fit into the data center. if all your installation or your plan are correct, if you didn't miss, for example, a bypass on the hydraulic network, if your cable tree and cable arm are enough, if your cable length was long enough to going from rack 1 to rack 30, etc., etc., etc. Check and prepare your schematics to be sure you will not miss any point and you will be ready for the installation. In the rack layout, just a little part on it. We saw previously we have to take care about the Ethernet connection, power connection, etc. In this specific case, we will have power supply at each side of a power supply. PDU, power distribution unit, at each side of the rack, and the power will going through the top. So we have to use the top hole to going through the cable tree for the power. We can see we have switch at the top, Ethernet and IB switch. So we will also have fiber and Ethernet copper signal through the top. So in this case, we prepare all the rack to be sure all the connection will going through the top. In this case, we of course check the cable tree size to be sure they will be fit enough for all the cable and prepare for maybe some feature evolution of the cluster. And we double check the hole on the top of the rack if it's large enough to fit all the Ethernet and InfiniBand cable and all the power cable. When we put server in rack, of course, the best way is to put the EV1 at the bottom part, just because you don't want to see your rack going down when you move it to the data center. And also for more flexibility, because you don't want to carry on a ready EV server at the top of the rack. So all their points have to be checked during the installation preparation. If we're going through the delivery and installation parts. First of all, the truck delivery. You have your team is ready, you plan some weeks, some days to come on site. You have to check you have access to the site. You have your badge, you have the security marked, you are ready to enter in full security. The guy are aware you come on site and will let you enter and lets you doing your job as good as possible. So the first point is access. The number of people, how many box, how many rack you will receive day 1, day 2, how many people you need to do the cabling, to put all the rack in place, material in place, server in place, etc. Just to be prepared and to manage all the people on site during the truck's delivery. Logistic aspects. Do you have a trans pallet? Do you have enough tool to carry on pallets, to carry on rack, to carry on materials? And the packaging checkup. If, for example, you deliver a rack in Dakar, Senegal, Diamando from Angers factory in France, they will travel during long time. They will travel across all the French, all the ocean, and a part of Senegal country. So of course, you will be able to have some damage on your package. So you have to check if all your security protection or your package are okay, and if your material are damaged or not. Because it's the only moment you will be able to do it. And it's the best moment because if some components are broken, you have to ask for a new one and you will have a lead time. So it's the moment to check up each packaging. The second part, you will be into the data center and you will install a rack and install server into the rack itself. You have to position the rack correctly between each other to be sure they are good aligned and they respect the side, the place itself. Be sure they will be in the good rank. If the front is in the hot, in the cold rank and the rear at the hot rank. Yeah, just be sure all is good and you position correctly each rack. For the racking, it's exactly what I explained previously. You have to put all the components inside the rack in a smart way. So the EV1 at the bottom, the connectivity at the top. If your signal going through the cable tree at the top, you will try to put the signal at the bottom. If all your cable going through the raised floor to the rack, etc. Be smart. And that's all for positioning and racking, I think. Yes, also be careful about the aesthetic aspects. Like I'm said before, the doors, the side panel, all the aesthetic aspects could be damaged and could disturb you for the installation. So it's the last part to put in place. If you can let your rack full open without door on it, without side panel to be damaged extra, it will be more easier to install rack and server into the rack. That's all for the racking and positioning parts. We'll going to the cooling and power parts. Do you have some questions on the previous parts?
No questions.
Okay, so we'll go on. Cooling and power part. If we're going on the cooling, of course, before you deliver all the rack, etc., you check all the cooling if is okay, ready to engage, etc. You will have to piping, connect the rack maybe, or connect the infrastructure. The best way is to have a plumber or qualified people to do it on site because it's not quite easy. You have to know what you are doing, etc. So have a qualified people, it's always useful. So you will connect the rack in case of direct cooling solution. You will connect the water cooler. You will connect maybe the heat exchanger. And you will open the valve. In case of when it will be the moment to open the valve, you have to think to check two words in mind. It's leak and air. Your system will be totally empty, so with a lot of air inside. So you have to double check, triple check the pressure and the water flow to be sure you will push the air from outside your system. And check also your air extractor. Generally, the simple one is this one, but you will be able to have more sophisticated installation. And you have to check if the air going out correctly, because again, air into your circuits could damage pump or other stuff like this. The other part, it's a leak. It's the first time your installation will be finished and almost in use. Maybe you will have a leak somewhere. You have to double check also if you didn't have any leak on the rack or on the installation itself. Generally, it's a leak from the plumber under the raised floor. The power, exactly the same. Are you qualified to do the power connection? An electrician with you? It's much better to do this job because it's a dangerous part and you will have to check it. Connecting the rack into the rack, it's quite easy. Connect the server to the PDU. It's a cable. Normally the PDU we did not have power inside at the beginning, so quite easy part. Connect the PDU, so the rack to the customer infrastructure. Just be careful if your fuse or your protection it's activate and your electricity is cut when you plug the PDU. And of course, after plugs all the electric parts, you will have to power on them carefully and check if the electricity is okay, going well, and if you didn't burn anything. So electricity connection is the beginning of the nightmare, because if you have any problem during the transport, little component moving, metal pieces going into two connection, you will have a short circuit, and it will be at this moment you will generate the short circuit. So again, be careful, take time, check and check again. That is for the power aspects. We will see the cabling, and for the cabling, you don't want to maintain this kind of system. An HPC cluster, it's a lot of cable. You will have really big quantity of cable, and you will always have to change a lot of cable during the cluster living, because when you will install cable, you will maybe broke one fiber or two fiber, you will have to change. Interconnect network is really sensitive, so it's really easy to have some disturbs on the connection, some problems. You don't want to have to maintain a system who look like that. So your best friend, cable tree, cable arms, good cabling, and you separate fiber, Ethernet, and power. If you didn't have the choice, you mix fiber and power, but it's a last case. Of course, we spoke about signal cabling. You can also manage, if you are responsible of it, the power cabling. A good power cabling, it's easier to manage, maintain, and will protect you from any damage, any problem. For the cabling, we will be able to see a big quantity of cable at the left side. It's switch rack. So into the switch rack, you will have really big quantity of cable. We can see they mixed also the color. If you want to make the difference between some virtual network or physical network into the cluster, mix color, it's really useful. For example, on some server, you will have the BMC, Blade Management Controller. It's not the same network than the management network, Ethernet network. Two different color, it's really useful when you want to maintain this cluster. Exactly the same when you mix signal, etc. You will have different color and different way. The best practice is to have the power from the bottom and the signal from the top. You will have much place to put in place your cable, and it will be really easier to maintain, and you will not have any parasite or any electric magnetics influence between the power and the signal. Also taking account that many HPC systems have blade, and you will have to extract blade from the server to change some CPU, memory DIMM, and so on. So have cable arm or correct connection like that could prevent you to change a single compute blade without disconnect another one. And that will be really useful if you have to change one blade and you didn't have to disconnect 3 or 4 blade. That is for the cabling parts. During an installation, also during an installation of cluster, it's the most time-consuming parts. One server mean 2, 3, or 4 connection, and you will easily have 2,000 connection for only 1,000 or 500 blade. So it's really the big time-consuming part into cluster installation. We're going to the starting and tests. Do you have some question previous parts? Or maybe it's a tea break also? I'm not sure.
Any questions? Questions? Anyone? Questions?
Thank you, Tom. I can see there are so many components. I want you to speak a little on, or I don't know, if all of them come from the same manufacturer or there's a baseline, there's a yardstick for the choice or a standard for your choice of which one is the preferred manufacturer for different components. Or advice, maybe advice on tips to consider while making your various choices. Do you understand?
Yeah, I understand. On an HPC cluster, as we see previously, you will have different kind of component, different kind of rack, different kind of nodes, storage, etc. First of all, you will have the compute node, different company, different kind of processor, etc. And you will be able to mix the different company. If you are, I would like to say, if you are really smart, you will be able to take one company who will be able to provide you all cluster, all solution cluster, because it will be easier to the different member of those company to work together. But the best maybe it's to going through the experts. For example, you want AMD, Intel, blade or component or server. Of course, you can take it from Gigabyte, Intel, Supermicro company directly. But you want experts to put it in place and have a specific server to be sure they will be okay for HPC. In this kind of situation, the best way is to going to the next HPC experts. So Atos, Cray, IBM, HP, Dell, Fujitsu. We have a lot of different companies like this. Generally, those companies will answer with a solution, a complete solution. So you will have compute blade, that is the most important part, management node, etc. Companies like that are smart. They will not be the best in all components, and they are not be able to provide all components. For example, you will be able to have a company who will provide you Supermicro server for the administration, IBM server for the compute node, because they are the best one for, I don't know, for the cooling, for example, because our cooling solution, HP is not bad so, but Atos are the best. Gigabyte server, I don't know for the gateway, because Gigabyte also are good with communication system, or of course you can get Mellanox for the interconnect, it's the best one. Cluster store for the storage, it's the best one on the market. You will be able to have a rack. You want a rack with a lot of space inside. You have the IBM rack, you have the DDN rack, who have a lot of space inside. Cabling, you don't want to do it, not matter. Ask a specific company who will do the physical installation and cabling. It's not a problem to have 5, 6, or 7 different companies to working on the single HPC project. The best way is to choose an HPC expert, a company, to manage all this project. But of course, you can choose the best component you want, or a specific component for a specific installation. If you are in a magnetics area and you don't want any copper cable, you can choose only fiber solution. It's not an issue. So going to the best fiber provider, low cost one, it's not a problem to mix material. And after all material, hardware parts, you will also have the software. That is the most important part, because each material could be compatible physically between each other. You will have to have a good software solution who will be able to manage and put all their components working together.
You're saying experience will be the best to inform you.
Yeah, I'm part of Atos, so yeah, maybe I'm not the best one to say, yeah, going to another provider. But an HPC company, I spoke about Atos, but also HP, Dell, IBM, etc. They are a big HPC provider, and they not have all the component into the cluster. For example, Atos have an interconnect solution named PXI, but we use it only in CA, FrenchMet, EDF, French company. Other company don't like big size solution. They want Mellanox or Intel OPS solution. Not a problem. We are able to work with it. So that is the feeling of each HPC company. We will be able to work with different kind of components and make them working together without any problem.
Okay, thank you, Tom. We actually should go for a tea break now, but the tea isn't ready. So I don't know if you could continue, maybe by 6:30 or 6:40. We go on break.
Yeah, no problem. 40?
Yes, 30 minutes time.
You're okay. It's a long break, but
No,
okay.
no,
No?
you continue to the next section. Then by 6:40, 4:40, we go on break.
Yeah, okay, for 6:40.
Four for us.
Yeah,
For you,
you,
for
yeah,
you,
for you it's
yeah.
yeah. Okay, okay, understand. It should be 5:40 for me and
Yes.
6:40 for you.
No, 4:40 for us.
For 4:40, sorry.
Yes.
International time. Uh, no problem, no problem. I can continue.
Yes.
Uh, or if other people have question.
No no questions.
Great. We didn't have a lot of section left, in fact. Starting and tests. Your cluster is in place. You pour on it, electricity, cooling, the network is ready. Now you have to test it. You have to double check the water and the power efficiency this time. Check if everything fine, if we push a little the system with a fire starter or some test like this to going at 100% use of your cluster, if the electricity is still okay, the cooling is still working well, if you didn't have any fire into the room or something like this, and tests the software. At this moment, two possibilities. Your material came with a pre-software installation, so a software made by your HPC provider, or the installation of the software began at this moment. So you will be able to test with the software if everything fine, if each component answer correctly, and it will be the beginning of a material and basic material test. You check if each BMC are okay in the good version, if each compute node answer properly, have the good performances, if all components are visible and working well, etc., etc. The first phase of the test is to check all the physical aspects of the cluster. And the beginning of the software could help you for all the internal component, if I can say that. The second part of the test, it's really more interesting. You will be able to check the hardware at the more I would like to say the more difficult situation. So you push your server at 100% usage. You push all your infrastructure at 100% and you see if you lose something. Maybe some server have little connection, electric connection problem or little component weakness or something like this. And you want to test it and to block it at the beginning if it's not strong enough. It's the moment to check each hardware weakness. It's also the moment to check your monitoring if you will be able to see the power increase, power consumption increase, water consumption, water temperature increase, etc. And it's a moment to check your software, if your software stack is correctly installed, if all the components are in place, and if all working properly. If the software stack is ready, the hardware is ready, and you didn't have a lot of, would like to say, compute node KO, just to remember, in a cluster you will have a lot of compute node. A little cluster is 200 compute node. A big cluster could be 2000 or 3000 compute node. So of course you will have some broken components. The factory, the different provider can't totally test and burn each component. You will always have almost 1 or 2 KO on site. So after testing all the component availability, you will be able to do the first performance test. It will be the first moment your cluster will be tested in the final version. So it will be the first moment you will be able to test if the performances planned by your provider, planned by you, planned by the benchmark expert are reached. If you reach the performance, if you have to adjust some configuration, software configuration parameter, if you have to adjust some hardware configuration to be able to reach the performance and to reach the goal, the performance goal. A second aspect could be the redundancy. An HPC cluster have a lot of redundancy points. You have the cooling redundancy into the rack itself if you are in direct cooling, the doors infrastructure. You will have a power supply redundancy between each rack. You will be able to have PDU redundancy because you will have two different power supply on data center parts. So you have to check all their redundancy if they're working well. Because, for example, if you have a server compute node, I don't know, air cooling compute node who going at the maximum capacity, generally it's 2.2 kilowatts or 2.4 kilowatts. If you lose one PSU on a system who have a redundancy at 1+1 PSU, the other PSU will take all the power consuming. So the ports on the PDU will get all the power consumption and your infrastructure have to be able to maintain it. That is a redundancy. So if when you shut down one PDU for the test, the other one goes down because the fuels was not enough, because your power supply was not enough, that could be a redundancy problem. And you have to get it at this moment because you will always be, it's always be possible to change it and to arrange it. Hardware verification, software verification, last verification for hardware and software, performances, redundancies. The last point after that should be the life of the cluster, the key in head, the maintenance. On this part, the cluster will not be the provider cluster, it's anybody, it's a customer cluster, K in end. So after all those tests, the customer have to be trained about the system itself, hardware using, software using. He have to, if he's responsible of the maintenance, he have to be trained for the maintenance of this cluster. He have to know which tool is useful for each manipulation. You have to have tool on site, specific room, specific component. If he needs some spare kits, spare components, it's the same. They have to be delivered. Trainings, it's also the moment that the provider will train people like we did, for example, in Senegal, but the cluster is not totally end, but training to how to use it, how to maintain it, etc. Specification, of course, you will have different kind of server, different kind of component. You will have really specific infrastructure, and you have to be trained for each of them. And of course, to have the specific knowledge. The support. It's also the moment that the HPC provider will start the support contract if it's the case, or will start the support contract, or send you some support guy if you have buy on-site support. And yeah, of course, the support is generally responsible of the training. For the monitoring, it's also interesting because a lot of different clusters didn't have monitoring before the end of the installation, and that is generally the beginning of the problem, because if your cluster is not monitoring correctly, you will not be able to see all the weakness, all the problem on this cluster. The monitoring is a really important part. You want to have the information directly if some compute nodes are broken, if some component didn't answer correctly, if you didn't have performances, if you have a leak inside the data center. So the best way is to have monitor with all the information on it. So for example, if you have a sysadmin room with some desk and sysadmin people, to have monitor into this room who will share directly all the technical problem, technical information on the cluster. And also the moment of the production. So the moment of share connection access to user, access to supports, external provider, etc. That is the beginning of the usage of the cluster. And the end of the delivery parts, the installation. And the end of this presentation. If you need more specific information on any parts, don't hesitate.
Okay. Thank you very much, Tom, for this beautiful and wonderful presentation. And it was very, very clear. Please, does anyone have any further questions on any part? Further questions? And I don't know, Tom, if you could share maybe an email in case someone has a further question, he can send you email. Yep.
Yeah, I don't know if I can share the presentation directly on Zoom or maybe an email. I can share directly this presentation diapositive, and you will be able to have my email and information at the end.
Okay, thank you. You can send the presentation to Bola via email.
Okay.
Yeah.
Yeah, okay. I will do it just after.
So does anyone have any final questions? Okay, question. Okay. Tom, you're saying you took away the slide with your details too fast.
Sorry, about which part?
The slide with your details, your email, like you took it away
Ah,
too fast.
sorry.
Yeah, thank you.
Question in the chat.
Okay.
The test to check the hardware integrity of the cluster.
There is a question on the chat.
Yeah, I'm see it. The tests for the hardware. When I'm spoke about the hardware test, generally spoke about Firestarter. Firestarter, it's the first hard tests for the material. You will push CPU, GPU in case of you have GPU, and memory at 100%. That is the best first test to do on material, because you will of course push the power consuming at 100%, but you will also push the temperature really high. So you will be able to test material and to test the cooling of the system plus the power of the system. That is the first test. Second test to do generally, it's for the bandwidth or for the storage. You have a simple DD test for the storage to see if you have the good transfer bandwidth, and for the network, an IO test simply to see if you have the good bandwidth, if the connection is stable, and yeah, if everything fine. And after that, one of the best tests could be an HPL, high performance tests like you will do for the top 500 classments. In this case, you have two kind of HPL. You have the mono nodes HPL. You will push the job on each node, and you have the multi-node HPL. The mononode in HPL, it's really useful to test the performances of an individual compute node, and also to test all the components working together, because the HPL, it's a real job. So you will test the processor working with the memory, working with GPU in some case, and working with working with the storage if you do it with storage usage. And for the multi-nodes HPL, the difference is compute node will work together. So at this moment, you will also test the network, the stability of the network, the stability of the access on each node together, and the access to the storage. That is the most simple test phase to put in place to check the hardware. So tool needed for the maintenance. I hope I answer correctly to the hardware test question. For the different tool, is it some for on-site test? So on-site tests, yeah, the test I'm just describe here. Normally, it's what we testing at the factory before shipping, but generally we did not have the full config at the factory before shipping. So it's exactly the same we do at the factory, and it's exactly the same that we will do on site with the final installation. That is a more efficient one, and generally the HPL parts will not be launched before the end of the software parts. So when we do it at the factory, we do it with quick software solution. And when we do it on the customer site after the installation, we do it with the final solution. So with the final config, and we are pretty sure we reach the performances we will reach the cluster. And we are sure of the hardware, of course. You're welcome. For the list of different tools needed for maintenance, generally is basics, screwdriver, some spare components, that is basics you need. And after that, depend of your material. For example, if you have a different, if you have a direct water cooling solution, you will need some yes, some tools to be able to dismount pipe, to dismount water connector, to dry them properly before dismount it, to be sure you will not generate a leak into your system, etc. That is for direct cooling parts. If you are responsible of the electric part of your installation, of your building, of course, multimeter, voltmeters, ohmmeters, ohmmeter, etc. will be needed. It's always depend of your material.
Any more questions, please? Questions? Questions from anyone, please? Tom, I think no more questions from this end. Okay, there is a question on the chat.
Yeah. Also, are there tests the same as the benchmarking procedure? The benchmarking procedure, it's can be put in place at the end of the software installation, because you will need the job scheduler, the OpenNPI environment, and all stuff like this. So at the beginning, when you just have a little software installation, I mean software, just a Linux on compute node and management node. The easier way is to do a fire starter or to push a stress test. Some kind of stress test as easier at the beginning of the software installation. Of course, you will generally not be able to put any tests on material before a minimum of software. The benchmarking tests, benchmarking procedure, of course, it's not always the best way. For example, if you use an HPL, it's a spike of activity, and after that it's not a lot, it's nothing. So you will have a spike at more than 100% of your power capacity, processor capacity, and just after it will be 100, 1900%, and that will decrease quickly. Then a fire starter will push you at 100%, and you will stay at 100%. An HPCG, for example, HPCC or HPCG, for example, will let your system at 80-90% usage for CPU and memory, but it will be more long. So you will not be full, but you have a long test. Different kind of benchmarking will allow you to test differently your system. I hope I answer correctly.
Okay, Tom. Thank you
Okay.
very much for the time spent with us today and for the knowledge that has been imparted on us. We greatly appreciate you and your team.
Yep.
And we know we are going to take it further from here. I know this is not going to be the end of the relationship. We are still going beyond here. And probably we know soonest you will come probably to one of the African countries, might be Nigeria, might be Benin, might be Cameroon, to come and impart this knowledge physically. And I believe you are looking forward for that day.
And I hope to come and see you directly in person.
Okay. Thank you very much for the time.
You're welcome.
Yes, sir. I don't know if you have any final remark that you want to just pass across.
No, nothing special. It was quick day, a lot of knowledge to share, and I hope it's will be useful for all of you.
Someone has a remark also, a personal remark.
Thank you, Tom. I have personally enjoyed the sessions, and I'm sure that I'm speaking the mind of others. We want to say thank you, and you sparked up a lot of imagination. Most of these things, I look forward to the implementation and all that. Thank you. It's been wonderful.
Thanks a lot.
Okay, we can call it a day. Thank you so much.
Thank you too.
Yeah, bye bye.
Have a nice day.
And you too.